All right, here we go. Synthetic division. Hopefully this is recording. Please be recording, please. All right, let's get my face out of there. Nobody cares about that. Okay, so we want to divide polynomials, right? We already did multiplication, we did addition, subtraction. Those are all child's play, super easy. Okay, synthetic division is actually another, it's not easy. I don't want to say it's easy, right? It's a little bit different. Okay, it's just different. I think you guys actually need some teaching when it comes to synthetic division. Adding and subtracting polynomials, I don't think we need any teaching. Okay, it's just combining like terms. Did I teach it? Yeah, but I'm sure you guys picked it up pretty quick. You guys are pretty smart. Okay, so here's the whole point of synthetic division. We're dividing a trinomial, a polynomial with 4 terms by a binomial. Okay, a polynomial with only 2 terms. Okay, it's the only time we can use synthetic division. Okay, so here's how it works. So first things first, you want to solve this binomial for x. Okay, so set it equal to 0, solve for x. Well, we know x is going to equal 2 here. Okay, so here's what we put on the outside. Okay, we're going to put a 2 on the outside of this big kind of half-looking box. Okay, and here's what's going to go on this top line. Okay, listen. It's going to be your coefficients of whatever is getting divided. Okay, it's going to be the coefficients of your trinomial, your polynomial with 4 terms. It's going to be all the coefficients in order. Okay, so that's already in standard form. It's the first thing we need to check. Now we need to just write the coefficients. Okay, so I have a 1 out in front of the x squared, so I'm going to put a 1 here. I have a negative 10 out in front of the x, I'm going to put a negative 10 here. Okay, and then I'm going to put a 2 for the constant. Okay, now here's the process. So my red is going to be my addition, and my blue is going to be my multiplication. Okay, here's the process. We're going to bring this 1 straight down. Okay. All right, now I'm going to multiply. 2 times 1 is going to give me 2. Put that in the next slot. Okay, then I'm going to add straight down. So I'm going to get negative 8 here. Okay, then I do this outside number, 2 times negative 8 is going to give me negative 16. I'm going to add straight down, and I'm going to get negative 14. Okay, so this negative 14 is called my remainder. Okay, so here's how I'm going to write this. Now, I need to know what kind of powers, what am I getting when I divide a trinomial by a binomial? Well, here's what you're getting. You're getting a whole new polynomial, but now, here's the only difference. So see how my highest power is 2. Let me erase that green so you can see it a little bit better. See how the highest power is 2 in my original trinomial. Okay, this new equation that I'm going to get down here is 1 power less. So it's just going to be an x, right? It's going to be 1 power less than the trinomial I'm starting with. Okay? So it's going to be x, and these are my coefficients. The numbers I just got down on the bottom row are x minus negative 8. Okay, minus 8, not negative 8, just minus 8. So let's put that in red. Okay, now is there going to be an x on minus 8? No, right? Because it's in standard form. It goes from the highest power to the lowest power. So we already have our x. Our next lowest is just going to be a constant, x to the 0 power. It's just going to be constant. And what do we do with this 14, this negative 14? Here's what we do with it. I put minus 14. And here's what I'm going to put it over. This is how we write our remainders. I'm going to put it over my binomial x minus 2. Okay, and this is my final answer. Okay, it's a little bit weird, but once you get good at it, you guys will do just fine. Once again, this right here is my remainder. That's how you write it. You write whatever that final number is, put it over your binomial. Okay, all right, let's try one a little bit harder. So 6. So once again, I want to solve this binomial, okay, for x. So I'm gonna get x equals negative 2. So that's how I know what goes on the outside. So negative 2. Draw your box. All right, now we're going to take our coefficients off this polynomial with 4 terms. So we're going to have 1 for my x cubed. I'm going to have 4 for my x squared, 6 for my x, and 4 for the constant. I put it right under for a reason. Okay, so now I need to do the whole process. Okay, so now I need to drop this first term straight down. So it's going to give me 1. Okay, now I got to multiply 1 times my number on the outside, which is -2. So it's going to give me -2. Add straight down. So I'm going to get 4 plus a -2, which is 4 minus 2, is going to give me 2. Okay, multiply -2 times this 2. I get -4. Okay, I'm going to get what? 6 minus 4 is 2. Okay, and then multiply again, -2 times 2. The number I just got is going to be -4. Add straight down, I'm going to get 0. Okay, so now I got 0 as a remainder. Okay, we'll talk about what that means in a second. But all that means now is that if I need to add my variables on here, my highest power is 3. Okay, so I know this is going to be a quadratic. Okay, so 1 less is going to be my next starting highest power. So it's going to be 1x squared plus 2x, right? Keep going less and less, plus 2. And do I need to add anything for the remainder? No, because it's just 0. So there we go. Okay? Okay, now what happens if, like in number 7, what happens if there's some gaps in our exponents, right? We see a cubed, but we don't see a squared or an x. That's what we're going to do. We need something called a placeholder. Okay, I know -3 is going to go on the outside because I'm going to solve that binomial. Okay, so once again, I'm going to take off the coefficients. So I'm going to have a 2 for my x cubed. Now, here's what we're going to do. We're going to add placeholders in for the x squared and the x. Okay, what placeholders do I want them to be? Like, what number do I want to put in there? Well, I want to put in something that, let's rewrite this so we can see it a little better. What if I just put 0x squared plus 0x minus 54? Is that the same thing? Yeah, it is, right? But the number is out in front. The coefficient is going to be 0 on the squared and the x. So that's what we're going to put when I say placeholder. We're going to put a 0 in. For my x squared, a 0 in for my x, and then a -54. If you don't do that, you're going to get an incorrect answer. Okay, you have to add the placeholders in synthetic division. That's kind of the kicker. Okay, so now we just do it just like we've been doing. So drop this 2 down, the first term. Let's multiply. 2 times -3 is going to be -6. Add straight down, it's going to give me -6. Multiply again. -3 times -6 is +18. Okay, add straight down, I get 18. This is going to be -54 is -3 times 18 is -54. They don't cancel, right? Don't get confused on that. It's going to be what? -108. Okay, there we go. So now let's rewrite our new polynomial. Okay, once again, the starting one was a cubed, highest power of 3. Okay, my new one's going to be a highest power of 2, so it's going to be a quadratic. So let's put our coefficients on our quadratic. -6x plus 18. And don't forget to write the remainder in this way. Put whatever the remainder number is over your binomial. Done. Okay, a little bit harder, but not too bad. All right, let's get crazy in the next one. Is it really that hard? No, not at all. Okay, synthetic division is very easy if you practice it. But if you look it up in Slater, it's going to be very confusing. Okay, so what number do I put on the outside? I put a 4 on the outside. How do I know that? Because I just solved that binomial for x. I added 4 to both sides. Okay, so I'm going to put 4 on the outside. What do I put on the inside? I put my coefficients of my starting polynomial. So I have 2, I have -11, plus 11, positive 11. Let's get rid of that plus out of there. There we go. Positive 11, 4, and 4. Did I need any placeholders in this one? Well, I don't, right? I have 4, 3, 2, 1, 0, blast off. So we're good. Okay, I didn't need a placeholder. Once again, the process, drop this straight down, I get 2. 4 times 2 is going to give me 8. Okay, add straight down, I get negative 11 plus 8 is going to be negative 3. Is that right? Yep, that's right. Okay, 4 times negative 3 is going to be negative 12. Ooh, that needs to be in blue, doesn't it? Stay consistent. Okay, there we go. Negative 12. So we add straight down. The colors mess me up. I get negative 1. 11 plus negative 12. 11 minus 12 is going to be negative 1. I get 4 times negative 1 is going to give me negative 4. I get 0. Okay, 4 times 0 is obviously going to be 0. Did I have it right the first time? I did, didn't I? I had it right the first time. No wonder I got messed up. My OCD kicks in so hard. Yeah, the multiplication is blue, the addition is red. Okay, 4 plus 0 is going to give me 4. It's going to be my remainder on my last term. And then now I just rewrite my polynomial. Okay, this is a quartic, right? This is a quartic, right? That's going to be the highest power. So what's going to be my new polynomial? Well, it's 1 less. Okay, it's going to be cubed. My new highest power is going to be 3 because my old one was 4. 1 less than 4 is 3. So we have 2x cubed, right, minus 3x squared minus x. Do I have a constant? I don't, right, because it's 0. All right, let's just write plus 0 so you guys don't get confused. And then we have the remainder plus 4 over x minus 4, our binomial. Okay, so right here, and it's going to be important, right here, right here, right here, and right here. Those are all our remainders. Okay? All right, so that's basic synthetic division. That's all we're doing. I'm not solving for anything. Okay, now the remainder theorem. What this says, I mean, it looks fancy, like all this, right? This looks super duper fancy. It's not. Okay, what it says is I'm going to plug 2 into the function using synthetic division. Okay, I'm going to evaluate this polynomial at x equals 2. Well, what do we normally do? We normally just plug it in and see what you get, right? Well, here's a different way to do it. And this is called the remainder theorem. We can actually do this by synthetic division. So whatever number I put out front, okay, is my x equals. So my x is equal to 2. I put the 2 out front. Okay, that's going to be the number I use now. Okay, so let's just see what happens. The remainder theorem says that my remainder here is going to be what x equals 2 is. When I plug in 2, that's going to be the remainder. So that's going to be what I am evaluating for. Okay, so let's do synthetic division just like we've done before. So let's pull off the coefficients. We have negative 3, 4, negative 17, negative 6. Do I need any placeholders? I don't, right? Because it's 3, 2, 1, 0. We're good. Okay, let's drop it straight down. So we have negative 3 here. 2 times negative 3 is going to be negative 6. 4 plus negative 6. 4 minus 6 is going to be negative 2. 2 times negative 2 is going to be negative 4. I get negative 21. Okay, and then we have 2 times negative 21 is going to be negative 42. Add straight down, I get negative 48. Okay. Now, negative 48 is going to be our remainder, right? That is what remainder theorem says, okay? So when I plug in 2 into this function, I'm going to get negative 48. It's just kind of a quicker way to do, to evaluate, so you don't have to plug in your calculator. Okay, it's just another way to evaluate a function using synthetic division. It's kind of cool, okay, but I'm a nerd. Let me check if I did this right. I did that pretty quick. Negative 6, 4 plus, yep. Hopefully I did. You guys will let me know if I didn't. Okay, next one, number 10. What number am I gonna put on the outside? I'm gonna put my x equals, right? Whatever my x equals, negative 1 is the number I'm gonna put outside. Okay, first thing I need to check for, do I need a placeholder? I have 4, I have 2, I have no 1, and I have no 0, or I do have a 0, right? So I'm gonna need a placeholder for my x cubed, and I'm gonna need a placeholder for my x. Okay, so I'm gonna need 2 placeholders. So let's pull off the coefficients. So I have -1, here's my placeholder, 0 for my cubed, 1 for the in front of the x squared, 0 for my x, okay, my x is the first, and then 4. Okay, so let's drop it straight down and do the whole process. Okay, -1 times -1 is going to be +1. Add those straight down. 0 plus 1 is obviously 1. 1 times 1 is going to be -1. Okay, add them straight down. I'm going to get 0. 1 plus a -1 is going to be 0. -1 times 0 is going to be 0. Add those. 0 plus 0 is obviously 0. And -1 times 0 again is going to be 0. Add those straight down. It's going to be negative, or it's going to be +4 is my remainder. Okay, +4 is my remainder, and that is my solution. Okay, everybody got that? Let me just check. Can you guys see this? I hope you can, because it's kind of cool. Let's go to materials. Let's go to chapter 4, part 1. Let's see if we did it right. Go to your filled in notes, and this is what you guys can do. You can print off a whole packet and you can do it. You can do it based on what I'm doing, and you can see if we did it right. Okay, we did do it right. Both these, we did them correctly. Okay, this is where you find the filled in notes. Some of you don't know that. Whew, it's okay. All right, let's keep going. Let's do one more, then I'll leave 12 for you guys. Okay, let's do number 11. Okay, so -5 goes on the outside. I want to evaluate this function at -5. Okay, do I need any placeholders? I have a 3, I have a 2, I have a 1, I have a 0. No, I do not. So let's just pull the coefficients off. Okay, drop the 1 straight down. -5 times 1 is going to be -5. -10 minus 5 is -15. Oh, what is -5 times -15? 5 times 10 is 50. It's going to be +75. Double check me. Okay. 31 plus 75 is going to be, we're getting big numbers now. I'm in trouble. 106. Okay, let's see about this one. -5 times 106. 5 times 100 is 500. 5 times 6 can be 30. 500 times or plus 30 is 530. I need to double check that, don't I? -530. Let me double check it. I don't want to tell you guys wrong. Hey, we did it right. Okay. So -530, add those up. It's supposed to be blue. Okay. Add those up. I get -560. So what's our answer going to be? Okay. What is our function? So this is how we write it in the math world. What is our function? What is our f evaluated at -5? Well, it's our remainder, right? That's what the remainder theorem says. -560. Answer, 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 answer. Okay, so that is evaluating a function using synthetic division. That is what the remainder theorem is. Don't get confused by the fancy symbols and wording. It's not that hard. Okay, all right, another thing I need to talk about. So if you want to check if a function or if a number is a 0 of the function, okay, so for example, if I were to plug in any one of these values, right? Any one of these -5, this 3, this -1, this 2, and I were to get 0 as a remainder, that would be a 0 of my function, okay? So another way to find the zeros is if you plug in, let's say if I plug in 3 and I get 0 as the remainder, a 3 would be my 0, one of the zeros of the function, of the polynomial. Okay, let's look above. Out of all these 4, which one is going to be, what's a 0? Which one is going to give you a 0 of a function? Well, -12 is not 0. -108 is not 0. 4 is not 0. But look at this one right here, guys. Is this extra? Yeah, it probably is, but it's good for you guys to know. Okay, that's the whole point of this, really. 2, negative 2, x equals, or x minus 2 is going to be x equals negative 2, right? I kind of wrote this funky. X equals negative 2. There we go. So negative 2, when I plug in negative 2 into this function, it's going to give me 0. So negative 2 is actually a 0 of this polynomial. So it crosses the x-axis. The graph crosses the x-axis at negative 2. Do you want proof? Sure, we got tons of time. You guys could probably click off the video now, but I'm bored. Okay, so let's go ahead and plug this function right here. This x cubed plus 4x squared plus 6x plus 4 into Desmos. Let's see what happens. Hopefully you guys can see this. Let me make sure. Let me make sure. Because I really want you to see this. Okay, what was that function? Oh, my memory's getting so bad. X cubed plus 4x squared plus 6x, x cubed plus 4x squared. I already forgot it. I'm a genius. Psych, we all know that. Plus 6x plus 4 plus 6x plus 4. Now, what did I say, right? I said negative 2 is going to be 0 of the function. Am I lying to you? I'm not. I am not. Okay, that's the whole point of the remainder theorem, really. Okay, can I find a 0 using synthetic division? Yeah, I can. Okay, if the number I plug in gives me a remainder 0, I know that it is a 0 of the function. Why is it called a 0? Because the y value, the output, gives me 0. Or it's where we cross the x-axis. Okay? That's all I got for you. Hopefully you stuck around for that. It's pretty cool, right? It's nerdy stuff, but it's cool stuff. It's kind of the cool things you can do with math. Everything's connected. All right, guys, stay on top of your homework. That's all I got for you. I guess I'll make another video on Thursday. All right, 4-4. All right, see you guys.